Hi everyone, we are going to solve systems of equations using the addition method, and I also call the addition method the elimination method because we are going to eliminate a term in order to solve for the other term. So let's take a look at this example. Now I'm going to add them together. Notice I have a 1y, right? And a negative 1y. When I add those together, it will be 0. So 4x and 2x is 6x. The y's give me just a 0, which is the whole point of this. And that's equal to 18. Right, I added the 13 and the 5. Divide by 6, and we find that x equals 3. Now I can use either equation and substitute in the 3 for x. So if I use the first equation, 4x plus y equals 13, and I substitute in the 3, notice that's 12. So I'm going to then subtract 12 on both sides, and I find that y is 1. So my ordered pair ends up as 3, 1. All right, next. Excuse me, I took a drink, my throat is dry. I'm going to rewrite these equations. That way you can see the original. Notice on the x's this time we have opposites. All right, so if I add 1x and negative 1x, I get 0. So I just drop that. We don't need the x written out. And that negative 2y plus 5y is 3y. Negative 11 plus 23 is 12. So we find that y equals 4. All right, so I'll use the second equation this time. Negative 1x plus 5y equals 23. I'm going to substitute in a 4 for y. And then I'll simplify that. That's a 20 equals 23 then. Subtract 20 on both sides. And we find that x equals 3. And so my ordered pair, negative x equals 3, and then we divide by negative 1, so x is negative 3. Almost dropped that off. Make sure you pay attention to that in the line above, okay? And so my ordered pair is negative 3, positive 4. Okay. So when you take a look at this one, you're going to see that we actually don't have any opposites, but we can make opposites if we multiply the equation by the right number. Okay, so I'm going to multiply the first equation by 3, right? Because that's going to give me 3y, and notice the other equation has a negative 3y. We're trying to create opposites here. So I'm going to rewrite this equation, 12x plus 3y equals negative 39. And then I'm just going to bring over the second equation and add these together. So when I add them together, I'm going to get 18x. 3y minus 3y is 0. And then I end up with a negative 54 when I add negative 39 and negative 15. I'm trying to write that number right. Divide to solve for x, and x happens to be negative 3 in this case. Whoops. Pick an equation to substitute back into, so I'll just take the first equation, 4x plus y equals negative 13. And so it's 4 times negative 3 plus y equals negative 13. I'm going to simplify 4 times negative 3 and then add 12 on both sides. So y equals negative 1. So that gives me that ordered pair, negative 3, negative 1. And that's that equation. All right, we're on to the next one. Okay, so this time I need to multiply the top equation by a negative 3, because notice I have a 3y and this is a 1y, so we're always looking for the simplest way to go. If I multiply this one times negative 3, make sure that you multiply all the terms. So that's going to be a negative 9x minus 3y equals negative 12. So 9x minus 9x is 0. 3y minus 3y, that's a 0. And on the other side, we'll just say 0 on this side. On the other side, I get negative 6. Well, that is not a true statement. 0 equals negative 6 is false. So this one happens to be no solution. And that's going to happen sometimes. So if that is a false statement, that's when we know we have a no solution as our answer. All right. So one more of these and then we'll stop this video. Notice that none of these can be opposites. This is the place where we're going to multiply by whatever it takes in order to get one of these as an opposite. It looks like we're going to have to multiply both equations. So let's just think about the x's. If I were to eliminate the x's, I would just have to multiply the first equation by 3, because that's going to give me negative 6x, and the second equation by 2. And then I would be able to eliminate my x's. So I'm going to multiply the first equation times 3. And I'm going to rewrite it over here. So that's negative 6x. Just trying to keep this organized is helpful. Negative 6x plus 9y equals 30. On the second equation, remember I'm going to multiply that so that I can get the opposite of negative 6x. So I multiplied this equation times 2. All right, so I get a 6x plus 8y equals 4. I'm going to add these two equations together, right? 6x minus 6x, that's 0. That's the whole point. 9 plus 8 is 17, and that's a 17y equals 34. To solve, we divide by 17 on both sides. So y is 2. All right, so now we're going to take another equation. So 3x plus 4y equals 2. It doesn't matter. You can use the first equation. You can use the second equation. Usually we go back to the original equation when we do this, but it would be okay if you use the negative 6x plus 9y equals 30 or the other one. Going back to the original equation, just make sure that you didn't have a mistake somewhere. So, whoops, we're going to substitute in for y 3x plus 4 times 2. Remember, 2 goes in for y. And then we're going to solve this little equation. That's 8 equals negative 2. I'm going to subtract the 8 on both sides. And then I have 3x equals, let me pause. Okay, so if you have a little glitch in your video right there, I noticed when I rewrote this up here, I put in a negative 2, which is not. Okay, so when I subtract the 8 on both sides, I end up with 3x equals negative 6. We're going to divide that by 3, and x equals negative 2. So my ordered pair this time is negative 2, 2. And that's the solution, and I'll stop this video. We'll finish this lesson on the next video.